And how about graphy?
Oh, if the writing will be written is a Greek prefix.
Lovely. Okay, so we've got color, we've got writing. So we kind of have to figure out, well, what is chromatography? So there are all kinds of chromatography, and today we're going to do paper chromatography. There's literally tons of kinds. You can do this with a gas chromatography, where they just use a big column packed with something, a material, and they choose the material that they're going to pack their column with when they do gas chromatography based on the physical properties of the two things they want to separate. We're choosing this material, paper, based on the physical properties of the two things that we want to separate. They can do this with DNA using a gel called gel electrophoresis, and it's essentially chromatography where you just pass an electrical current through a DNA sample on this gel, and the electrical current makes the DNA move through the gel, and it moves at a different rate based on what it contains. Just to simplify that complicated process. So you can do this with a gas and a column. You can do this with DNA and gel. You can do this all kinds of ways with all kinds of different media based on what you want to separate, like amino acids or whatever. We're going to do it with paper, and we're going to separate these two molecules. A few terms that you might need to know. Maybe you want to make a note, like on the back. I know you don't have much of a back since the fake printout is on the back, but you can use that big open space for note taking. There in chromatography, there is a mobile phase. In our case, we're going to use water. I don't know where I put the water. The mobile phase today will be water. And I chose water as the mobile phase because it's cheap and I have lots of it. And also because both of these red food dyes are water soluble. So they both will dissolve in the water and move along with the water. I chose a stationary phase. Stationary phase, almost like a pun when you choose paper for your stationary phase. But, you know, I could choose packing for a column for gas. I could choose silica gel if I'm doing amino acids. But today I chose paper because I'm separating these guys based on the size of the molecule. So what do you think will happen as the water draws them up? So we've talked about hydrogen bonding and the properties of water. We've looked at how water forms a meniscus in our graduated cylinder because of its surface tension. Have you guys learned about capillary action? Physical science, capillary action. So maybe in biology, I know you did, biology. I read the biology book last year. We have a heart that pumps our blood. There are blood vessels, right? Do trees have a heart? A pump? A mechanism?
Not exactly. They have a silent or flow.
And how does the water go up through one and down through the other?
It was through the cohesion, right?
Cohesion. Okay, so that's what I'm calling capillary action. So water just wants to climb up because of its polarity, its properties. So when we stick the end of our paper into the water will just seep up the paper against gravity even, because those water molecules cling to each other, to paper, and they'll go up. And since the sample is soluble in water, it'll get carried along with it. But the size of the molecule will determine how high. The bigger molecule will experience just as much force downward because of gravity as upward because of that cohesion of the water climbing up the paper. This is capillary action at some point. But a smaller molecule will be able to go higher before gravity has the same downward force as the capillary action has upward force. So we'll expect a big molecule to stop lower on the paper and a smaller molecule to be able to go a little higher before gravity pulls down as much as capillary action pushes up. So our mobile phase is water, stationary phase is the filter paper. And those two things are always going to be present in chromatography, whether it's paper or some other type. And you're always just going to use the fact that one thing with different properties will travel further than another thing. We're using molecule size, just like you see in the layers of the atmosphere, how up closer to space you get a layer of oxygen, which is a larger molecule than the next layer, which is helium, and then the next layer is hydrogen. They sort themselves out based on molecule size. It's big molecules on the bottom because they experience more effect of gravity. So that's exactly what we're hoping to see here. So I'll just tell you, and your lab help sheet tells you this in case you forget or don't write it down, which you probably should right now, that red 3 is a big molecule and red 40 is a smaller molecule. So which one would we expect to go up lower and which one would we expect to go up more in paper?
Red 3 would go up higher, right?
Red 3 is bigger.
Oh, no, I'm sorry.
Yeah.
Then reverse.
Yeah, reverse. So red 3 will go up just a little bit, and then gravity will stop it because it's big and heavy. It's actually a tiny molecule, but it's, big compared to red 40, which will go up more. So what we need to do is set up the experiment. Now, were we talking about this, or was it physics last week, how pencil does not dissolve in water at all?
We weren't talking about
No, physics, we talked about that because somebody was writing on their clothing, and I said that will never come out, pencil doesn't come out of clothing. And I know this because Elizabeth drew on her Easter dress one year, and it didn't come out. No matter what I did, I tried everything. And
you tried an eraser?
Yes, but it damages, it was like satin, and, nothing worked. It wouldn't also damage the dress. So pencil, your pencil won't dissolve. So if you have a pen, borrow someone's pencil, and let's follow the procedure, which I will now read. It says, draw a pencil line straight across the bottom of the chromatography paper about 1.5 inches from the bottom of the paper. So, like if we're saying your cup, say maybe this is the inch, so like, something like just a little more than the line on your cup, you want to draw the line that high.
You guys have microscopes in here?
No. Sorry. So,
What is it?
draw a pencil line across the bottom of your piece of chromatography paper. Oh, you're actually going to measure. Yeah. Okay, 1 inch would do. It says 1.5 inches, but let's go for 1 inch. And I'll pass out some water here.
Straight.
As the water comes around, you can add enough water to the bottom of your cup just to fill it to this first kind of big line, not the really low line where just the bottom is, but like this line here. So put water, pass it down, draw your pencil line, and then you all who have markers will have kind of an easier time of it. So you're going to make dots essentially. So here we go. You're just going to take your markers and make little dots. That is the next step. I forgot anything. So you want the dots to touch, and you don't want to write on the table, especially if things there's a permanent marker. So, like, here, we'll put the extra quiz and everything else under there. So when you make your dots and they go through, hopefully they won't hit the table. So, hold on, I'll do it here. You're going to draw your line at about 1 inch from the bottom of your paper with pencil, because pen sometimes might bleed up a little bit. Pencil really isn't going to go anywhere. Then you're going to take your red sample. If you have a marker, you're going to make the teeny tiniest dots right at the bottom of the pencil line, and the dots need to touch. And they need to be rather small and in a nice straight line. And you go across the bottom like that. If you have a liquid sample,
Right under the line or on the line?
right, like under, like make sure you know where you're doing it so you can measure from that point. Make sure the dots on the sample touch. Yeah, I know. Yours is going to be an interesting problem. If you have a liquid sample, you're going to take a toothpick and you're going to dip it into your sample, you guys. I don't know, I'll have to find some
Let's
little
not make dots.
dish or something. Oh no, hold on, I'll look at it.
Hey, quill and a bender.
Yeah.
Quill and
This
ink.
Essentially,
open.
you're going to just dip it in there and, do we have an extra cup? No, no extra cup. Yeah, maybe we'll just be careful and take the lid off. And then, here we go. It's like shedding that. Okay, so just dip the toothpaste in and make the little row of connected tiny dots as tiny as possible. If you mess up, there's more chromatography paper.
Oh, a long one.
Jen, you're going to bite that open and make a tiny row of dots. Is it mine or yours? This line is so not straight. Do it again. Yeah, you have the absolutely hardest one, that's why.
I don't know how it's gonna work.
Yeah, yours is very challenging. Maybe let me put a little bit more sprinkle in there so we get more concentrated.
Yeah, I can't do anything. Just
Here, like really, really stir with your toothpick. Yep, and then go back over it if it's quite light.
This is gonna work.
Who knows? They obviously dyed it, so yes. That's okay. That's okay. Just keep dotting away.
Dots? That's not happening. Dots are not happening.
Okay. Yeah, yours is going to be fraught with error. But I want to see what it will do, like if we can get any results out of that. It's hard to come up with a new thing to test that's exciting. Okay, so once you've done that, you're going to tape it to your skewer and essentially roll it up with a scroll. Everyone made a scroll in kindergarten, Sunday school, right?
I was wondering.
Wow. Hold on. Let's just... Yeah, the tape. Tape it to that and then roll it up like a scroll. So we've got kind of a range for you instead of a thing. All right. So, yeah, you just keep on dotting.
I don't know either. We don't know how to make scrolls.
So I would lay it on here and tape it, and then I'd wrap it around so it rolls around it. So maybe I'll film better. Just like, is there a way to pause, Jenny, or I'm angering it? So we've got
That looks like a dot.
sample,
It kind of bled
beautiful. It's not focusing at all, but yeah, that's exactly it. And then you wrap it around like a scroll and have it taped. It doesn't matter. You're just going to tape it and wrap it.
like that.
Yep. And try not to smudge your sample.
Should I keep it tight or?
Well, we'll all do it at the same time because time is a factor in chromatography. We want to get it so that the whole sample goes as far as it will go, but we also know that that might be a factor. So what we need to do is make sure that the control has the same amount of time to go up the paper as every other sample. So we don't want somebody to put it in now and then the control goes in 5 minutes. We want to try to get it all timed at the same moment. Is this going to work? Not at all. So sorry for anyone who's getting nauseated watching this, if anyone ever does. Alright, we'll be perfect. Wow. Okay. Oh.